Hey, welcome, David. We'll get started here in just a moment or two. So thanks for joining. Welcome all. We'll get started here in just about another 30 seconds or so. All right, let's go ahead and get started. So welcome to today's session. My name is Josh Brothheim. I'm the training manager at Sumo Logic. If you attended yesterday, which I think you guys did, I was training. And what we're going to be doing today is observability fundamentals. So we're going to go through, like we did yesterday, or if you've done a previous class with us, a 3-hour class, and we're going to get into observability. So I got an agenda, a couple of slides to kind of set the table. The objectives for this class. So what we want you to walk away knowing. So you're going to learn about, of course, observability solution and the components of the observability solution. And we're going to talk specifically about 3 pillars of the observability solution: metrics, tracing, and logs. And you're going to hear that repeated many times because it's that important. If you joined us yesterday for metrics, you already kind of know one of the pillars, but we're going to be going through all 3 together. And we're going to be doing so with the use of some tools and technologies within Sumo Logic. So we're going to use what we call RCE, or more specifically, Root Cause Explorer, to do some troubleshooting or identify the root cause of what's occurring or what isn't occurring, as the case may be. And then we're going to do something with tracing. So we'll get to play around with that as well. So a bunch of labs for you today, but the agenda is essentially as such. Doing the welcome and agenda right now. Going to do a semi-brief introduction on what is observability, so we're all speaking the same language, if you will. Then we're going to look at metrics and Root Cause Explorer and show you what that tool is and why it's helpful. And then we're going to do a lab utilizing that tool. So we'll get into Sumo Logic and use RCE to play around and find the root cause of what's occurring. Then we'll do some slides on tracing, and then we'll jump back into our labs. So a little slide heavy today, but not too bad. The later part is less slide heavy. Once again, today will be 3 hours, 2 hours of content, and 1 hour for the exam. And so you guys will take that at the end of today's class. And we'll take a break in about an hour or so. As a reminder as well, we are continuing to offer our Uber Eats promotion. So if you take one of our classes and take the exam, and more importantly, pass the exam, you're eligible for a $15 Uber Eats voucher. And if you take an exam today and tomorrow, that's 2 exams taken, and that's $30. So excuse me, encourage you to take advantage of this. Let me go and put the link in the chat, and I'll post it again later, just so you have that. There we go. So that should be in the chat right now. All right. So what is observability? So that's what we want to talk about. Now, before we talk directly about observability, we want to talk a little bit about Sumo Logic. You've probably seen the slide before. I hope you have. If not, I'm going to go through it kind of briefly. But what we're showing here is Sumo Logic, and specifically the continuous intelligence platform that we offer. We also refer to it as SIP, CIP. So you might hear that acronym floated around a little bit. It's old Sumo Logic, or traditional Sumo Logic, rather, excuse me. So it's what we're known for. There's other components of Sumo Logic, Cloud SIM, things like that, that really fall under continuous intelligence platform, or SIP. With SIP, there's many ways that Sumo can help you. Operational intelligence, Sumo can help you and start to see what is going on in your environment as far as what's occurring, things like that. Security intelligence. Do you want to look through logs and see who logged in, when they logged in, did they log in multiple times from the same place? Is that a security issue? That can be done through Sumo. Business intelligence, how many widgets were ordered, when were they ordered, Was there an increase in orders? Things like that. And then global intelligence, kind of your company or your organization on a global scale compared to other regions. Now, Sumo Logic is going to benefit, or not benefit, but going to require your data, because without your data, Sumo Logic really doesn't do much. It needs your data to process, to do something with. And your data is going to be in many different formats around the world and in many different environments as well. So you might be generating app data. You might be generating microservices data. You might be utilizing cloud systems and infrastructure like AWS, where you have various regions around the world, SaaS services, mobile devices. There's probably some other types of data that's being generated that I don't have on this list. And essentially it all needs to come into Sumo Logic for you to start to utilize it. Now, once it's in Sumo Logic, then you can apply our analytics against it. You have the benefit of multi-tenancy, and the systems are scalable and have elasticity to them. Machine learning, APIs, advanced analytics. We'll look at, actually not really much of that today, but those are cool features of Sumo. Certainly there's security and monitoring built in. On the right-hand side of the screen, these attestations or certification are important to us, important to our customers, and so we're very proud that we have PCI compliance, HIPAA, FedRAMP, and many others that aren't on this list. And then who can benefit from Sumo Logic? Well, fortunately, your entire organization can, not just DevOps or engineering, but IT and customer success, et cetera. They can all get a glimpse into your environment, your organization, whatever it might be, and get an understanding of what's happening or not happening and do things based off of that. And so that's good. That's important. Now, that's what Sumo Logic does. There we go. But what is observability? So observability is the ability to observe and understand the whole state of an application, such as our coffee app. So what we're going to be using for an example today is Sumo Logic Coffee. You might be familiar with us, very similar to a company with a green logo. It's a fictitious company, but for today, we'll imagine it's a production environment, and we'll use the example in more detail later. But for now, imagine there's a coffee app that's out there. With observability, we can observe an app from the outside and understand what's happening inside it. Observability is going to help ensure that the app is running reliably. In other words, the system is set up and running. It's functioning well, or as expected, or is secure. Observability makes sure your app's resources are used as accessed and as intended under all the circumstances. And so what we have here is the observation of that app for a failure or success, then the notification and alerting component, and then doing something, making some sort of conclusion, using some of our tools that we offer, like we'll see shortly, like RCE, and then taking that action. What are you going to do about it? And then that's probably going to repeat all day, but that's what observability is. At least our definition of it. There's many ways to define it, but I think ours is pretty good. It's simply the ability to observe and understand the whole state of an application. Now, come on, slide. There we go. Now, I mentioned the 3 pillars of observability. Easy for me to say. And those are going to be logs, metrics, and traces, as we see right here. Oh, sorry, my mouse animations are being weird, so I apologize. And so once again, we see those 3: logs, metrics, tracing. Around observability, they're complementary to each other, and they need to be together in a single platform. And together they can offer more in a single product than in 3 separate products. But what is the need to have an observability solution? Why do we want an observability solution? Well, we're relying here on the foundation of the customer experience and having the customer have a good experience, very simply. And so reliability is the basis of that. It's the new requirement across applications. When enterprises deliver new applications, they have to ensure that it's highly available, it's performing well, it's secure and compliant to enterprise requirements. And there's going to be real business impacts of not delivering high performance apps. So for example, 100 milliseconds of downtime might not sound like a lot. It's 1/10 of a second, but that's been shown, and there's evidence that it has reduced e-commerce sales by 1% for a well-known CDN or content delivery network service provider. So 100 milliseconds reduced sales by 1%. Another example of performance being an issue, there was some latency, 0.5 seconds of latency. Once again, does not sound like a lot, although as we all know, it kind of is because we're in a high demand environment now, but 0.5 seconds latency for a giant search engine, it dropped their traffic by 20%, which is quite meaningful. Another example, DDoS attacks. And actually this needs to be updated, this slide, because what we're showing here is that DDoS attacks are anticipated to double to 14.5 million by 2022. We're now in 2022. I actually need to get a new slide of how much they're supposed to increase by. But as you know and see in the news all the time, DDoS attacks and similar issues around security are on top of mind of really everybody. And so having negative experiences results in a negative customer experience. So to ensure reliability, an organization needs to have a unified platform that's going to continuously monitor the app, diagnose the issues, and fix them as soon as possible. And that's why we need an observability solution. Now, in this slide, what I wanted to talk about is the difference between observability and monitoring. Some people use them interchangeably, and there's, of course, similarity between the two, but there is a difference, and I wanted to discuss that. So when we talk about observability and monitoring, when we talk about monitoring specifically, we're talking about being able to being able to see what is occurring in regards to the collection and displaying of data. So when we create a monitor, we can do so, and that monitor is going to tell us about the state of a system by looking at the parts that we have configured to monitor. If a part of the system isn't monitored and we haven't configured it to be monitored and we're not monitoring it, well, then we really have no idea what's happening there. And knowing something is wrong is, of course, quite important. Now, with monitoring, we need to know about the functioning of our apps, but also its growth, its utilization. And so observability is going to go beyond monitoring by bringing together those logs, those metrics, those traces to give us a broader view and a deeper context, knowing something is wrong, but then being able to find out why. And so that's really the big difference there. All right, a few more slides here, actually a bunch more, but we're getting there. Now, why Sumo Logic's observability solution? I hope in the kind of previous slides, I've sold you on the importance of an observability solution, but now once again, why Sumo specifically? Well, there's two key requirements for an observability solution. First, the observability solution should be able to handle large-scale data sets. So while monitoring and diagnosing requires working with some amount of data, it's that troubleshooting phase where the observability system should be able to handle unlimited amounts of data from logs, metrics, and traces. And this is a challenge for many observability solutions that don't have a high-end and scalable solution. Well, fortunately for you, we are built on a cloud-native architecture, and so Sumo Logic enables the ingestion and storage of any amount of data in a highly elastic and scalable and flexible way. Now, secondly, the observability solution needs to have a highly scalable analytics engine. Observability is going to require us to use lots of data machine learning and other initiative search-driven analytic capabilities. So as a large-scale data analytics platform, Sumo Logic provides out-of-the-box capabilities to support the ingestion and analytics for almost any amount of data. Not almost, for any amount of data, period. The observability solution is going to provide the tools that work together to ensure the ability to, once again, monitor, troubleshoot, and diagnose issues across a variety of environments. And so what I'm trying to show in this slide is a few things. In the, I have an iceberg here, and that's the kind of allegory I'm using here. And so at the very top of the iceberg is the what. If you want to monitor your data, you can do so fairly easily, and that you can find out what's gone wrong. And to do so, you need about 20% of your data. Now, as you want to get deeper into diagnosing and troubleshooting, more data is required. And by adding more data, we can get more information and get the where, the why, the how, which is going to give us more insight, not just knowing what has gone wrong, but where it went wrong, why it went wrong, and how it went wrong are very valuable pieces of information. And so that's what I'm trying to demonstrate here. As you get deeper in the iceberg and want more information, more data is going to be required, and you're going to need to have more sophisticated analytics. And that's where Sumo Logic fits in quite nicely. All right. I'm going to skip ahead of this slide, just kind of getting into that same idea that once again, monitoring, diagnosing, and troubleshooting. And so that theme will consist across, well, certainly the next few slides and across the content of today's class. So monitoring, diagnosing, troubleshooting. That's don't really need that, but once again, same idea. And then another view of the same content. So as you get deeper into monitoring, diagnosing, and troubleshooting, you need more data. And here's the more data that you might need. You might need to get into your logs, get into those traces. And as we do so, and when we do so, and you'll see in the labs, that's going to give us better understanding of the where, the why, and the how. And that's really what this slide is trying to show. All right, one more, well, a few more, but a couple more slides here. So what I wanted to show here with this one is an observability value. So we have a few different people on the line, might have different roles, and wanted to just help you understand how observability might be able to help you in your role. You probably already have a pretty good understanding of how observability can help you. If you're here, you already kind of know that observability can help, but here's a few examples just to kind of throw them out. So this slide is going to show three different groups of users that can benefit from observability. And so the first one is the DevOps or SER team. Those individuals that are responsible for monitoring the health of the application. Well, they're going to need observability so that they can quickly monitor, diagnose, and troubleshoot application health issues. For the software engineer on the team, observability is going to provide them visibility into the software pipeline. And so by collecting information about that software pipeline and identifying issues with the software delivery process, teams can improve the quality as well as the delivery of their application. Now, from a security standpoint, DevSecOps, security teams can utilize observability to ensure the security posture of their applications. And what's unique about the Sumo Logic observability solution is that it addresses the needs of all these teams and personas in one integrated platform. All right, so let me go ahead and kind of skip to these next slides. Okay. And there we go. What I wanted to do is now start to get into, as it's still on the screen, metrics and root cause explorer, or as we refer to it as RCE. So what I'm going to do is, let's see, how should we do this? I'll do a quick demo, and then we'll get logged in together and start messing around. So let's actually, we'll just do the screenshots. So to understand the role of metrics in the observability solution, what we want to do is get to a scenario where an app using AWS faces an unusual delay while loading. And we're going to see how RCE, which is a powerful Sumo Logic feature, uses metrics to monitor the app, analyze the data, can help us identify the root cause of the incident fairly quickly. And it's going to enable us to take measures to resolve the issue as well as prevent future occurrences. So what is Root Cause Explorer? Well, here it is, or at least a screenshot of it. Once again, when we get in the app, it's a little more exciting. But what we're seeing in here is, well, a lot of different things. What we have the ability to do is start to utilize Root Cause Explorer to go ahead and get a understanding of what is occurring in our system. So our system is notifying us of, as we see on the bottom left here, events of interest, or EOIs as we'll refer to them. With the EOIs, we can start to see what Sumo Logic, or more specifically Root Cause Explorer, has categorized various events as. And so, for example, on this screen, we see 4 events have been identified. We see that they're errors based on the color scheme here. We see a timeline telling us when over the last 3 hours this event of interest occurred. We see the y-axis with the percentage, which is showing us, we call it drift. It's essentially a deviation from the norm. A higher event is more abnormal. And then we have a whole slew of filtering options at the top, which we'll show you shortly, so that we can start to filter on just AWS data or just Kubernetes, or many filtering options as many filters work. Let's see. So what RCE is going to allow us to do is, as mentioned, help troubleshoot those incidents that are running on a specific environment, and we can filter down to that environment. And where the events of interest are going to help us or are be utilized is the system is going to look for these unusual spikes in these many different environments: AWS CloudWatch metrics, OpenTelemetry, Kubernetes metrics, and others. And so we can take many different environments and look at them through our CEE, either together or isolated using the filtering options. As we start to see these events of interest, if resources are connected based on a service map, and we'll show that later, Root Cause Explorer may group multiple events of interest into a single point. And so just because there are 4 circles here does not necessarily mean there's 4 events. There may be more, and we'll see that in app shortly. Here's this really the same screen, just a lot more busy. And so what we're seeing are a variety of different events, a lot more in this case. And so we see some loads, some bottlenecks, we see some latency issues, we see some errors, and the system is putting these on the timeline to start to let us know, hey, we had some errors, then we had some latency, then we had some bottlenecks. And what we're going to be able to do is utilize that to start to see what happened in the breakdown of a process, how it's supposed to go and how it didn't go. And the didn't portion will help us troubleshoot what didn't work and why. And so we'll be able to do that shortly. All right, let's see. I mentioned the events of interest drift by time, this box that's highlighted right here. There is another view where you can look at count by time as well. So it's kind of taking this view and looking at it top down, just another way to get an understanding of what's occurring. And then what we also have, I have so many screenshots of basically the same thing, is what we see on the right-hand side of the screen are those entities that are associated with these events. So we're going to start to see if a bottleneck occurred. Well, more specifically, a bottleneck was associated with DynamoDB at a specific time on a specific date. And so we just don't see a bottleneck, we see a bottleneck specifically at such and such. We see an error at a specific node. Is there a correlation between that node and that bottleneck? Maybe, maybe not. And that's where we can start to dig. And when we get in-app, we'll see that better. Let's see, these are basically the same screen. Here's just showing the ability for you to utilize the filtering. So we have the ability for you to utilize the AWS and host metrics. You can turn them on, you can turn them off, you can turn them on and then just look for a specific region. So filtering many options. All right, let's get in app because just showing it to you is not great. So let's do 2 things. We're going to go ahead and log in together. So I'm going to go ahead and put these training credentials in the chat. These are not the same ones from yesterday. I think yesterday we used the admin one. So this is a different set. So go ahead and use these for today. And so there we go. So the credentials are in the chat. And let me go ahead and put the lab guide. And then I'll go through these together. Lab guide, here it is. Okay, so those should be in the chat as well. So what we're doing for login is going to service.sumologic.com. The account we're going to use is training plus analyst number. So I want you to select a 3-digit number. Maybe you want to be training plus analyst 007, training plus analyst 123, pick a 3-digit number at sumologic.com. And then that password for this month with July 4th passing is fireworks ! So trying to be a little thematic. And then also open the PDF. So I'm going to log in with you. Once you log in, if you want to just put your number in there, just as confirmation that you logged in successfully. If there's overlap for the numbers, it really doesn't matter for today. If you need help, of course, holler in the chat. So actually, let me log out of this account. I want to log in as the same account as you. So training plus analyst 234 at sumologic.com. And my password is fireworks ! So once you get logged in, you should be brought to not necessarily this screen, but Sumo Logic. I'm going to close these tabs. I was doing other lab exercises, so I'm just going to close all tabs. And ultimately, what I'd like you to get to is the home screen. Now, at the same time, I want you to get that lab guide ready. So open up that PDF and have that handy as well. And now I'm going to really just pause for a moment or two and make sure we're all together. All right, so we should be logged in. We should be have our lab guide. We should be good to go. So I think we're all okay. All right, so I'm going to keep going. So I got my lab guide. And so now we're going to utilize the lab guide. Now, lab 0 is just logging into the system. So if you logged in successfully, you are halfway there, which is great. But now we're going to go ahead and get into lab 1. Now, before we, let me think how to do this, because the lab actually has us doing some other steps first. I'm going to follow the lab guide. So before we get into RCE, I'm going to show you another section of the system, which is going to be the Explore tab. And so let's look at it. So we're going to follow the lab guide. Yeah, let's follow the lab guide. Let's see where it takes us. So what we're going to do is we're going to go up to the plus new icon. And we're going to go to Explore. Now, later we will go to root cause, but for right now, let's go to the Explore and let's show you what we want to show you in the lab guide. So when we go to new Explore, what we see is our Explore by tab or section. And so what this Explorer does, and by default, you might not see any data, don't panic yet. What it's showing us is the ability to explore by various views. And by default, not by default, but most likely the view you have here is probably Kubernetes service view. This is not the Kubernetes class. And so while that view is good, it might be displaying on your screen, it might not be. That's not really relevant for today. What we want to do is go to Explore by and select AWS Observability, because we're talking about observability. Now, when I do, I start to get, hopefully I get data. And what I'm starting to see is information about my environment. Now, under this Explore by AWS Observability, I have different accounts. And what these different accounts represent are different AWS accounts. In that, I have a production account. I have a staging account. I have a development account. I have mobile banking account for, imagine this is a production environment. And so I can start to go into each one of these and start to get an understanding of my system. So production is probably going to be something I want to look at. When I click on production or prod, I now see and am observing, or I'm starting to observe various information about my production environment. Where did people log in? Information about the load balancers. Right here at a high level view, I have a honeycomb showing me good, bad. As we go down, EC2 information, and so on and so forth. And, yeah, really just so on and so forth, a lot more information. Now I can start to utilize my filter on the left-hand side of the screen to get more specific. Do I want to look at my production data? Sure. Do I want to look at US East 1 or US East 2? Well, maybe this is not US East 1, US East 2. Maybe this is this is APAC and US. And so I can say, maybe just look at US East 2. And I get more insight into my AWS environment. So now I'm starting to see within US East 2, the services, or in this case, as we'll refer to them as namespaces that are being utilized. Do I want to look at my DynamoDB AWS information? Do I want to look at my Lambda information, my network ELB information, so on and so forth? And feel free to just poke around in here. I kind of expect you to just click on stuff. Everything should work. Some things might not work just because, like I showed you earlier with the view we were putting in by default, that just isn't doesn't have data, but everything else in here is kind of live. Is it possible to break down further by AZ? So there's actually different views we'll show you as well. So up here, you can start to do some filtering. So the short answer is you should be able to, just maybe not on this screen. Now, what I wanted to do, or what the lab wants us to do, as I was guiding us, is taking a look at prod, looking at US East 1. And what we can do here is, under our dashboards, we have a few different options. The option that is, most of these I want you to ignore because they're not really relevant for today's conversation, although you feel free to poke around in them. But the one we want to look at is the AWS Region Events of Interest, the EOIs. Now, what this is going to show us is it's like a junior version of root cause explorer. I guess that's a okay way to say it. What it's doing is it's showing us, it's going to take a few moments to load, but what it's doing is now looking at production data of the US East 1 region and looking at all these events of interest, or finding all these events of interest. It's finding all these unique things and starting to group them together. And what we're going to start to do is utilize this grouping to find an issue that has occurred and start to understand why it has occurred. But as you go ahead, feel free to click on the EOIs, or events of interest. When you do, on the right-hand side of the screen, you're going to get more information about them. So for example, here I see a bottleneck. If I click on it, I get more information. Although actually not much more. We'll get a lot more when we get into the real RCE. But I start to get to see the grouped events that preceded it. So here we have an EC2 bottleneck. Here we have a DynamoDB bottleneck. Are the two related? Maybe, maybe not. And actually they are, because they've occurred within the US East region during a similar time period. And we're going to look at that example, like I said, just in a few moments. What I want us to do now is actually go into the real RCE. So what we want to do here is go to the top of the screen, go to, oh, actually, did we move it again? Let me see. Okay, what we're going to do is, I apologize, the lab guide changed possibly this afternoon. What I want us to do to get to the root cause explorer from here, or not from here, but through here, is go to plus new and go to root cause. And what that's going to open up is the full root cause explorer. Once again, it's going to take a few moments to open up, just because it's going to actively look for those events that have occurred. By default, it should look for the last 3 hours worth of time. You can modify that, of course, but that's fine for right now. When we get into the lab example, or a little deeper, we will want to modify this time. But for right now, it's okay just to poke around in here. Now, what we want to do, though, is we do want to utilize some filters. So what we can do is go to the top of the screen, and now we can start to filter. Do we want to look at Kubernetes data? Well, not really for this example. This example is really a little bit more about AWS data. And same thing with the application service, just not really relevant here. Now, what I do want to get, and this is where I do need to adjust my time period. Actually, we can do this two ways. Well, actually, we need, yeah, sorry. We can go ahead and adjust the time period. What I want to do is the last, I think I'm going to do the last 24 hours to get what I'm looking for, because I'm looking for a specific series of events. Now, the other thing I'm going to do to clean this up, and it's going to run while I'm doing this, is modify this information over here. For the account ID, let me see. I want to put the region as US East 1. Actually, that's just enough. Just doing the US East 1, and let me see if there's anything else I need to do in here just for this example. No, that should be it. Now, when I do that, what I want us to focus on in here is this mess that's occurring right here. And what we see here is our EC2 having some errors. If I click on these, specifically this one, yeah, either one, I start to see our metrics here. And what I'm seeing in here are metrics related to read throttle events. And what I'm seeing here is a high or large spike here, letting us know some abnormality is taking place with these read throttle events. Sorry, easy for me to say. Now I also see, let's see, am I seeing what I want? Let me just try one thing here, because it should be filtering just a touch further. Let's see, why is it not allowing me? And what I'm looking for is, so what I'm looking for is there should be an error at 6 a.m. 6 a.m. my time, Pacific time. But I'm not seeing. That's not it. Oh, this is a bummer if it's not showing up. Because let me show you what we're trying to do with this lab. What I'm trying to show in here is, let me go a little bit further back. Let's close this. So prod, US East 1. Okay. Now, what do we want? What the, come on, where is it? I apologize. I think we changed this lab around recently. All right, here's what I'm trying to show. What I'm looking at right now is our load balancer. And specifically what I want to point out here is these 500 errors by the load balancer. And so what I'm seeing is a spike, and specifically that spike around 6 a.m., really more around 5 a.m. This morning. And so the goal, or the idea behind this lab, was to start to troubleshoot that and get a better understanding of what's occurring. So what I want to do is, let's see, I should be able to open that. Yeah, it's not bringing in my bottlenecks. Let me try one more thing here. Just gonna try one more thing. I don't want to get too hung up on this. I mean, I wanted to show it properly, but the system's not behaving. these look like they're working. So what we're trying to show here is the idea that we have a bottleneck. There we go. As you can see, they're replicating these bunch of oranges with the red down below. And the idea behind it is it should be showing the fact that we have a DynamoDB bottleneck and we have an EC2 bottleneck at about the same time. And what we wanted to show here is a correlation in a overusage of the right throttle, not overusage, but a an overusage, I guess, of the right throttle events spiking. And that's what's the kind of the culprit here. But it's not really letting me show that story. Well, so I don't want to dwell on this too much, but I do want to, well, let's see, because if it does get us stuck in the lab guide, let's just see where we can go from here. So we should see that ELB app error. That should be right there. So what we see here is that spike of the 500 count. So what we're seeing is a bunch of more, a high amount of errors, an abnormality in the amount of errors that's occurring right now. And then we should be able to take that into our entities. And what this allows us to do is start to do some correlation. But it's not giving me. What I'm looking for is a DynamoDB throttling that's occurring, and it's just not showing up for me. Here's the DynamoDB. There's the bottleneck. Yeah, so we should be seeing some correlation between the DynamoDB throttling and the 500 errors. And what it should start to let us do is, I'm going to kind of jump ahead, I guess, here, is start to utilize our entities, or has previously been referred to as infrastructure. And what we should be able to do is start to open our entities in a specific dashboard so that we can go ahead and take a look at the DynamoDB, for example, in an entity dashboard. And what I should see here, yeah, see, it's not taking me to the right spot. Let me go one level down. And so what we should see, this is where it's not exactly correct, but we should start to look at our DynamoDB events that have occurred, see that there's some errors that have occurred, and correlate those errors to the relevant logs that have been provided or associated with what went wrong, which was once again, that spike. So basically an error was occurred because somebody had misconfigured the right capacity. And that's what we're seeing right here. But I'm not seeing it as thoroughly as I should. So I do apologize for this story being just broken, really, to be honest. But I hope you're able to see, at least just playing around with Root Cause Explorer, what it's doing, in that it is taking these events of interest, which are, like I said earlier, kind of abnormalities, and correlating them and providing some timetable with them, and allowing us to see other events that have occurred associated with those, and then start to dig into those events. Yeah, and then the lab goes into looking into the logs, but that portion won't work because that log isn't there. Let's just try one more thing. Yeah, so it should allow me to go to. So what I'm doing here is now I'm looking at the logs, and what I would be looking for or want to look for is a specific log that is going to show me that essentially Bob or Jason modified the right capacity incorrectly, which resulted in just chaos and spikes and 500 errors. So I do apologize that that story doesn't work as well, because it's when it works, it's very impressive. And this is not, but nevertheless, we're doing it live and things happen. And so I do apologize. Well, let's see where we are, where we're up to. All right, let's go back to our deck here. Now my deck's slow, just everything's going good. All right, so what we were going to do is we were going to look at the Explore. We were going to look at, or did look at, that Explore tab. I might be able to do it through these slides. We looked at the regions of the AWS region events of interest. That open and root cause Explorer does not exist anymore. And once again, I just apologize for that. And what it would bring us into is root cause Explorer with that filter set of prod, US East 1, and just that information that's relevant. And what we should have seen is these events of interest. That's what I was trying to look for. They were kind of there, but not really the way they should be. So there was a DynamoDB bottleneck. And then what I wanted to do was go into the entity dashboard for that bottleneck and find that error. More specifically, finding that table being updated. And what I see it down here in the top errors, and I also see it in the logs, is that validation error. So what happened is Duke, who's one of our, well, he's one of our very good employees. In this case, he's just a guinea pig, or really a scapegoat. But what he did is he did a incorrect validation, incorrect provisioning, excuse me, of the right capacity units, and that blew everything up essentially. And so that's, like I said, what we were trying to show you. Now, through that bumpy demonstration, there were a couple different troubleshooting concepts that I was trying to get across, and I didn't as well as I had hoped to, but the concepts themselves are still valuable. And so RCE is going to base itself on 6 troubleshooting concepts. And so the first one is around abnormal spikes in the metrics. Abnormal spikes in the metrics represent a statistical anomaly, and they're going to indicate that there's some underlying issue. Larger spikes compared to the expected baseline and longer lasting spikes are going to require closer attention than other spikes. Kind of obvious, but worth mentioning. Now, another troubleshooting concept is going to be context and correlation. Analyzing the spikes with context and correlating events, correlation in the events of interest is going to be essential to utilizing RCE. In large deployments, there might be thousands of AWS CloudWatch, tracing, or Kubernetes metrics that may be anomalous over the course of an outage or an incident, and might make it impossible for an on-call user to deduce which resources might be related to the root cause. With the ability to correlate those EOIs, those events of interest based on context, Root Cause Explorer can significantly accelerate that incident triage and root cause isolation. The third concept is connections. Connections between the resources and the services will help us understand the topology in related EOIs and gauge the root cause. So those connections of what has occurred, very important. Knowing the connections between the resources and the services can help a user trace problems from top-level symptoms to upstream root causes. Fourth is earlier spikes. Kind of mentioned it with the abnormal spikes, but earlier spikes are going to be closer to the root cause. In a complex system, resources or services that break at the early stages of an incident are closer to the probable cause than resources that experience spikes later. And so Root Cause Explorer exploits this insight to display spikes on a timeline. 2 more. Fifth one is the exploration of logs as well as trace data. And kind of started to get in there a little bit, but by identifying the actual root cause, we can, identifying the actual root cause is going to require exploration of log and trace data. And so we're going to need to drill down the event logs and trace the actual root cause based on previous analysis to help pinpoint the actual root cause. And then finally, golden signals. SREs are going to be familiar with the golden signals of load, latency, bottleneck, and errors, and we start to see those EOIs. In a nutshell, errors and latency are signals that most affected users are going to be impacted because the service is going to either be inaccessible or slow. And Root Cause Explorer is going to classify each AWS CloudWatch and/or Kubernetes metric into one of the golden signals to help users navigate spikes that utilize these golden signals and help you arrive at the root cause. All right, the next thing I want to do is get into tracing. So tracing is going to be an essential pillar of observability because it's going to provide context for the other components of observability. And so what we can do is we can analyze a trace to identify the most valuable metrics based on what we're trying to accomplish. And so let's see how tracing kind of fits in here. So traditionally, metrics have been used to provide classic monitoring, but it's only going to look for the known failure conditions of the application. Observability, on the other hand, requires us to completely understand the application so that we can identify, troubleshoot, and fix any conditions, known or unknown, about the application and its health. And to gain insights from the collected data that's just being collected, is collecting the metrics and the logs. That's not enough. We're going to require more than that. So when those logs and metrics are used together, they might be sufficient to understand the performance and behavior of individual systems, but they're not going to be sufficient to understand the lifetime of a request that traverses multiple systems. Distributed tracing, also just known as tracing, is going to be a technique that addresses the problem of bringing visibility into the lifetime of a request across several systems. Troubleshooting problems real time in distributed dynamic cloud and microservices environments is very difficult. But with transaction traces, it's going to be a lot easier because we're going to be able to see the details about what exactly is happening and how it affects or impacts our users. So what is tracing? Tracing is a significant technique used in monitoring modern applications that use distributed microservices architectures. A transaction trace is going to give us a detailed snapshot of a single transaction lifespan across our application environment. So we're taking a transaction trace. It's going to be the snapshot of a single transaction across our entire application environment. That trace is going to follow the course of a user's request or a system call from the source to the ultimate destination. We can use transaction tracing to start to profile and monitor microservices-based apps and architectures, locate failures and improve performance. And logs, metrics, and traces serve their own unique purpose and are going to be complementary. And in unison, as mentioned earlier, they're going to perform or provide those three pillars of the observability system. In a microservices environment, when a customer is facing issues, it can be extremely difficult to track down what service is the culprit or the root cause of the issue. One transaction or a call from the customer could potentially interact with dozens of services. Transaction tracing is going to provide the engineers or the SREs or developers the observability that they need to quickly identify the problem service within transactions. And this is going to speed up the mean time to identify issues. So once again, we can use transaction tracing to monitor apps, look for failures, improve performance. And so what I have here is an example of tracing in a more common example, and that's getting a package received or sent to you and receiving it. And so what we have the ability to do is when we get that package sent, we get a tracking number or tracing number, and that allows us to see all the different hops and stops and occurrences of that package. When did it get shipped? Where did it get shipped from? What process? Oh, in this case, it went from Arizona to Ohio. Then it went to Pennsylvania. We can see here, did it stay in Pennsylvania a long time? Should have been a shorter time, and so on and so forth. That gives us this insight. And so that's, yeah, I think that's probably, they're just the best example of tracing. Now, what we're going to do is introduce, although, and this is just kind of reiterating, we have our user interface, and logging in might take various steps and traces, where logging out might use different services. And so we can start to utilize tracing to look at those experiences. Now I'm going to introduce the Coffee app, which I already introduced earlier. But once again, we have our Sumo Logic Coffee. Remember, we're a production environment, we are worldwide, easy for me to say. We have an application that allows you to order coffee. So that's the scenario we're putting forth for today. Now, let's talk about coffee and what a successful order at Sumo Logic Coffee looks like. So essentially, ordering a cup of coffee is a series of microservices. What happens? How does it work? Well, first, the customer is going to place their order. They're going to use our app. They might call over the phone. They might do it in person. For our scenario, they're going to use the app, but the customer is going to place that order for coffee. The order is going to post to the barista. And so that barista is going to do the manual labor here. And actually, that coffee machine is going to be doing most of the labor. So the barista is going to interact with the coffee machine and set it, turn it on, do what it needs to do. Now the machine's going to do some work here. It's going to make sure that it has the appropriate amount of ingredients. It's going to take those ingredients and start to utilize them. So it's going to make sure that it has the right amount of beans, and then it's going to grind those beans. It's going to make sure that it has the right amount of water. And if it does, it's going to add the water to the cup of coffee. Magic is going to occur, and then that coffee is going to be ready for the customer. Customer is going to need to pay for that order utilizing a credit card. And then once that's approved, then the customer can pick up the order. And so, like I said, each step is essentially like a microservice. Now, let's take this a little bit further. Here we have Abel, and Abel is a coffee lover. He loves using Sumo Logic Coffee. He loves drinking it, and he loves our services. Now, he uses our great app, and when he does so, the experience he has is basically he orders the coffee and the barista turns on the coffee machine. Now from there, various other services are going to start to come into play. That machine service that's going to check the ingredients and make sure it has the right amount of ingredients and levels before it does what it needs to do. There's the payment system side of things, where once again, we don't offer free coffee. Abel needs to pay for it. And so the system is going to go ahead and start to calculate what item he ordered, how much each item costs using some SQL records, using a calculator service to start to say, you know, this plus this and add on tax, and that now you have your total bill, if you will. So how does tracing work in here? Well, to understand tracing, let's consider the example where Abel orders a cup of coffee. So we have our client. He orders coffee, and the barista starts to prepare that cup of coffee. Once he's done with that preparation, the coffee cup is delivered. Now, Abel, the client, orders that coffee, and it's going to wait some time for the barista to prepare and deliver the coffee. It might be a second or two. It might be a few minutes. Various variables will impact the time that our barista takes, but that period of time is going to be referred to as a span. So the entire transaction is referred to as a span. And this span is going to have a beginning time and an end time, as well as some detail or tag about the type of operation being performed. So the client knows about the request and the response. He knows what he ordered. He knows when it was ordered. He knows what he received back and when he received the order. The barista knows something similar, but from their own perspective. They know when the request was received and when it was responded to. And though ordering and receiving coffee is a single transaction, it does go through those steps that I described. And each step is going to be a small span with a beginning and ending time. And it can be tracked closely. And so a transaction is actually going to consist of several spans. Now, what's missing here is a third entity. We have the client, and he knows what occurred from his point of view. We have the barista, and he knows what occurred from his point of view. But that third entity, we need to link the client and the barista and track the transaction span by span and gain insights about the transaction. And so what we're going to utilize here is what is called an observer. In order to start creating that complete picture of the interaction, this outside observer is going to gather information about the interactions between the client and the barista. So with help from the observer, that observer is going to start to look at the interactions holistically and gain a better insight by looking at the complete picture. So here we have our Sumo tracing, we have the observer. And in this example, let's say the client and barista know about the observer and report every time they send or receive data. And they are going to tell, and once again, the system, not necessarily they, but they're going to tell the observer about who they are, what they're interacting with, when they're sending and receiving data, timestamps, what data is being sent and received. And so an interaction is going to start to look a little bit differently. What an interaction is now going to start to look like is a client is going to send a coffee order to the barista at what is going to be labeled at time 0. At time 1, the barista is going to receive that coffee request from the client. The barista is going to process the order and deliver that cup of coffee, which is going to occur at time 2. Now at time 3 is when client is actually going to receive that cup of coffee from the barista. And so Sumo's logic tracing feature is going to act as that observer and allow us to be able to correspond events of two-party interactions as a contiguous group of information, so that we can start to see where did the most amount of latency occur. Was there a delay in the network between the client and the barista? Was there latency? Why was there latency? And that's where we're going to start to get to. Now, we've gauged 4 steps in this transaction, but let's take it a step further and break the process of the barista into multiple steps. And so what we're starting to see are those steps right here. But this next screenshot or slide starts to show these spans and traces. So what we're looking at here is a single order. So with our trace ID is going to be, as it shows, coffee equest 1 is our essentially our order number, our tracing number, our tracking number, but we have multiple spans. So we can go ahead and look at the first span, which is going to show us the client sending coffee order to the barista. Did something go wrong there? Okay, that was timely. Let's look at the second span, and we're going to start to do that shortly. And so this is just providing that visual of what we're going to see in a few moments. All right, a couple more slides, and then we'll get into the lab exercise. So I want to talk about service maps. What service maps are a constantly updating diagram or a map of the services and the interactions they have with each other. And each service is going to be shown as a bubble, and we're going to have an arrow that's going to connect services which call one another. The visual of it, when we see it in a moment, will be much better. In fact, let me just show the visual, and I'll just describe it. So in the service map, what we start to see here is these various applications, or more specifically services, and how they are interacting with one another. So in this example that's popping up on the screen, for example, we see all the aspects of our coffee bar app. We see some colors here, specifically blue and red, red being bad or error or anomalies. And so we see that there are some anomalies here. When the system mouses over them, we see there's some issues with latency. And so this is starting to show us where the latency is occurring. In this case, the latency is associated with the coffee bar and the coffee machine. And so we can start to utilize that to drill in or zoom in and get a better understanding of what's occurring there. So as described, I don't know why the slides are kind of repetitive. We see the high level, blue normal, red bad, or anomaly, which usually is kind of bad. And we get to get that insight. What we'll also have access to are some settings so that we can modify as it says here, the anomaly detection. And so we can start to adjust what KPIs are going to be utilized for that anomaly detection. If it's using the outlier, we can start to modify the threshold. This is something we cover more in our, where do we do outlier? Our search mastery class. But it's the same idea of outlier. All right, let's do a few more. Let's see, where are we? Let me just see if we should do probably a few more slides, and then we'll do a lab. Let's see, traces. So what we're showing here, let me show these slides and then we'll do this together. We'll do lab 2 together. Although I have a little concern that's going to work properly as well, but we'll cross that bridge when we get to it. What we're going to start to look at are the traces. And here's a screenshot of them. Actually, let's just go into the app. Let's just do this together. What I'm going to do is I'm going to utilize my lab guide and just jump into lab 2. And we'll just go through this together. I think we'll be better. So what I'm going to do is I'm going to go back into Sumo Logic. And where I want to start is with service maps. So what I want to do is go to plus new at the top of the screen and select the service map option. When I select it, it's going to open up. It's also going to pre-populate. It might give you a little explanation of service maps. And so feel free to read this because it should be mimicking what I'm telling you about service maps. And what we see here is everything. Now, remember, we're in a training environment, and so we're actually seeing more stuff than we need because we're seeing everything. So what I want us to do is go up to the top of the screen under the application name and just select the Coffee Bar app. So we can just use our Coffee Bar example here. And it should clean things up a little bit. And so what it's showing us now are those services. It's showing us even a little bit about the language of the service, if it's Ruby on Rails or JSON or what have you. If we hover on them, we see what is the issue, latency. And then on the right-hand side of the screen, when we click on one of these, we see the entity inspector. And so we can go ahead and take one of these and open them in traces. So what I want us to do is go ahead right now, go to the water service, click on it, and now go to open in traces. Now we're in the tracing environment. Going to take a moment to load. The screenshots might be a touch different than what you have. But what we're now starting to see are these traces. So what I'm seeing here is each trace ID, each transaction ID. This is somebody ordering a cup of coffee. This is somebody else, somebody else, somebody else. I'm seeing when that transaction started. So what time did the observer determine that this transaction, essentially the person clicked the order button or maybe opened the app, depending on what is the measurement of starting it, which I guess would be an order. The duration. So how long did the order take? Remember, we're trying to give or serve a fast cup of coffee. Speed is important. So that's going to be relevant. We also see a duration breakdown. So we start to see the various services that are part of each order, and we get a visual understanding of the percentage utilization of those services. So for this transaction, the most amount of usage was in the Lambda check suites function, and then that can be helpful for us as well. What I want us to do in the lab guide, the lab guide's not going to play nicely with us again here. What I want us to do is open one of these traces, specifically not the one that has a bunch of yellow, but any of the other ones really. So I'm going to just open a trace. I'm kind of gambling here that this works. And it's not working the way I want. Let me just try one more. All right. So what I want us to look for is, let me take a little step back here. So when I click on one of these traces, I then get the trace overview. I get the whole experience of that trace. And so I'm just going to click one at random right now. What I see here, once again, are those services and the duration. And down below, I get a better breakout. I see in a timeline what occurred when. I also see a red line. And what the red line represents is an error. And in most cases, that's probably going to be important to me because we're trying to look for errors and look for bad coffee experiences. So what I want to do is I want to find a red line and I want to look at the lowest level of the red line because that's going to point and tell me what has gone wrong here. This order has a red line, and so something has gone wrong. If I grab a different one, hopefully it has a red line as well. By clicking on the red line, it's going to start to, or not even click, mousing over it is a good start. It's going to start to show me the service that has been impacted. So in this case, there's been an issue with this transaction, and it's associated specifically with the cache desk. Now, what I'm going to do here is I'm going to click on that lowest level of red line. And now I can start to utilize my logs. And so my logs are going to start to indicate to me what has gone wrong here. Why was there an error? And this is not following with the lab guide, so I'm kind of gambling if this works. Not gambling, it should work. But let me go ahead and now check. What I want to do is now open this log, and hopefully I'm getting an indication of what has occurred. So we're now looking at the specific transaction. And I start to see what has gone wrong. I see an order here for a coffee, for somebody ordering coffee. It looks like they're also ordering Cornetto as well. The system is getting the price of that Cornetto. The system is querying the database to get the price. And then what we have here is an error. And so we see that there's a problem at this point. And so the transaction or the tracing here is indicating where the specific issue has occurred, what it's associated with, and then we can start to troubleshoot it even further. Now, the example I was looking for is, let me see if I can find one real fast. I don't want to take too much time here. Is one of these lines down here, either on the brown or on the blue. And what I wanted to show here is clicking on the coffee service and opening the logs. And what this example will show is a better example. What we see here is an order was received for coffee grains, and the system did not have enough coffee grains in it. And so we're able to use this tracing to start to look at this order, look at where something went wrong, understand why it went wrong, and then we need to make some decision on how to impact it. So in this case, where there was not enough coffee grains in the machine, maybe we need to just make our machine have more coffee grains and add a bigger storage bin or something like that. And so that's where we can start to take our experiences through tracing and start to figure out what has happened and why. And then, of course, how to prevent it in the future. All right, these labs have been rough, but I apologize, we're getting through them. What we're going to do now is we'll take a break, and then we'll come back and we'll finish up. So let's go ahead. I'm going to put the timer on. We'll do another 10-minute timer. And so go ahead, grab a beverage, grab a snack, and then come on back and we'll finish up. So let's get this timer going. Cool, and we're away. So talk to you all in a few moments, and yeah, have a good break. All right, welcome back from break. Hopefully you had a few moments to yourself. And so what we're going to do is just pick up and keep going. And this last part won't be as long as the first part. So let me go into the deck just to kind of mildly keep me honest on what we're doing. Let's see, spans. Let's just see if we're going to do that next. Let me go, where are we? Logs. Here we go. All right, so a couple slides. Really, I think there's just 2 or so here, and then we'll get back into the lab guide. And so what we want to talk about is now observability with logs. As a reminder, with the observability solution, we talked about metrics at the beginning. We talked about tracing just a few moments ago. And now we're going to talk about logs to tie together that observability solution. So logs in Sumo Logic, hopefully you're familiar with logs in Sumo Logic. If not, a log, or is referred to as a log message, is going to be a system-generated string of text when an event has happened to describe an event. And so a log message is going to contain log data. The log data will contain details about the event, maybe what resource was accessed, who accessed it, at what time. And each event in a system is going to have different sets of data in the message. And so Sumo Logic can collect, of course, your logs, metrics, and traces and put them in one place. And that's done through a process called collection. Don't really go too much deeper on it. Now let's go ahead and start to look at our lab activity. So what we're going to do with our lab activity is we're going to go ahead and start to troubleshoot utilizing logs to help us. Fingers crossed. So let's go ahead and start to do our example. So I'm going to get out of my deck. I'm going to go back into Sumo, and I'm going to open up lab 3. So in lab 3, the scenario here is we've been alerted about an incident. We want to deep dive into our logs, and specifically we're an SRE. So we're an SRE and we've got an alert of an incident. The end users have been experiencing an outage in the Coffee app, specifically in the US East 1 area. And we get an alert that something is related to Lambda, or there's a problem associated with Lambda. And so we want to start to dig in and see what's going on and try and figure out how to solve it as well. So in this case, I'm going to close all these other windows. They're just noisy. But I'm going to go to New, and I'm going to go to Explore. Once again, this puts us in the Explore by view. It should retain your previous option of AWS Observability. If it doesn't, go ahead and select it up here. And now we're going to look at the region that's relevant to us. So we're going to look at our production account and then our US East 1 region. And we started to kind of look at this stuff earlier. Now, what we're going to look at here, because we know it's a Lambda issue, is Lambda. Kind of makes sense. Now, in this Lambda overview, what I'm getting presented by default is audit and performance data. And as it says in the lab guide, what I want to do is I want to scroll down. And what I want to point out, or what I'm kind of looking for here, is the services that are using AWS Lambda's functions. I see the users that are using Lambda functions. I also see the success and, more importantly, the failures, and probably more important, the errors here. And so what I see here is that there are a lot of errors. When I look at this errors over here, and it's going to be, let me move that guy over. What I want to point out here is here we see all the error messages. But in this case, what we're interested in is that number 1 error message. It's occurred 716 times, so that's a lot of errors. And we also have a pretty kind of clear understanding of what the error is associated with. I mean, there's a database authentication issue and invalid credential. I think we all can kind of, sort of figure that out. But what we're going to do here is we're going to clean this up a little bit. We have the ability, as we get into our levels of our account, we can start to look for or filter information. And in this case, what I'm going to do is I'm going to filter specifically on the get billing info function, because I want to look at that function specifically. I want more information about it to try and figure out what's just more information about what's occurring and why. So what I'm going to do here is I'm going to go to the very top and I'm going to type in get_billing info. Search ahead should work for me, and so that's kind of what I'm waiting for, just to make sure I don't fat finger it, but it's also taking longer than it should as well. So just type it out. And so when I specify that function, now everything down below in this dashboard is customized to only show that function. So now we see a lot less errors because we're just looking at the errors associated with get billing info. As we see, there's, well, in the lab guide it says 720, here it's 716, close enough, but we start to see those errors. Now, what we can do here and what we want to do is we want to now look at the log messages that are associated with these errors. So what I'm going to do is I'm going to go over to right here. So I went to my success versus failed requests, and I'm going to go ahead and open in log search. Now, when I do, here is the entire query that's being utilized. It's kind of long. Don't really need to know it, but there is that query. By default, we get put in an aggregates view, but we can look at the raw log messages, and we do so just very simply by clicking on messages. And so now I'm looking at these raw log messages. We can utilize the field browser that's built in here. So we can go ahead and start to specify just specific logs that we want to look for. In this case, what we're trying to look for or trying to find, and this is another place where I'm afraid it's not going to work as well as I hope, is I should be finding a culprit, essentially Mark Smith, that is showing up in the records as having basically having the incorrect credentials. So his credentials are wrong, but I don't see it here. Let's see. Yeah, I'm missing another field here. I see the error message. I don't see Mark Smith in here. All right, I don't want to waste too much time looking for him because not a good use of our time as a group. But that's what I should be finding in here. And that was kind of the goal, is to find a specific log message that indicates a specific user did a specific function. And so really getting down to that level of that event that the logs show us. All right, but that's all right. It's close enough. Let's finish this off. Let's finish with lab 4, which is working with logs. What we're going to do here is now utilize our log search query. Some of this you probably know, or hopefully you kind of know some of it already, but we're going to go ahead and play around with it anyhow. So what I'm going to do here is I'm going to grab this query that is in lab 4 step 1, and I'm going to copy and paste it. So I'm going to do a new log search, and I'm going to paste that 3-line or 4-line query. What this query is doing when I run it is it's going to look for my CloudTrail data. It's going to look for fields, specifically a field called AWS region. And it's going to call that field AWS region with all lowercase. And then it's going to count those AWS regions. So I'm going to do a search. And so this is log behavior or log querying. Like I said earlier, you might have done this in Search Mastery. I certainly hope you have. But the reason why we're showing this and wrapping it up with this is it's that other tenant of that observability solution. Logs, metrics, traces. We did metrics, we did traces. Now we're finishing up with logs. So what we see here when we run this query is we get aggregated data. And so I can very nicely see through my logs what regions are being utilized over a specific time period. I can also look at the raw messages themselves. So what I see here in the aggregates, I see there's 2,300 results. In the raw messages, I now see each one of those messages. So there's 25 per page, 25 times 95 should get roughly to 2353. And so now I start to see these log messages. Now, something I want to do here is, and this is not the greatest example, but nonetheless, I'm going to modify my query just a touch. I'm going to basically get rid of that count operator. And what I want to introduce here is the use of log reduce. What log reduce is going to allow us to do, or allow the system to do, is take these log messages, these 2,300 log messages, and look for patterns within them and group them together based on pattern recognition and AI and machine learning and secret sauce and all this algorithms, fancy tech words. But what we do when we click log reduce is we'll take a few moments. Remember, it's looking through 2,300 records. And it's looking at each record and it's looking for a pattern, and then looking at the next record and looking at a pattern. And now once it's done, it's going to group those records based on those patterns. Now, like I said, this is not the greatest example, but nonetheless, it's the example we're using. And what we see here are the patterns. So there were 1,200 log messages that matched this pattern. 383 that matched this pattern, and so on and so forth. And so what it's allowing us to do is start to look at the count and also start to look at the uniqueness. So by flipping the count around, I can see that this type of log message only showed up one time, and that might be relevant to me. Now, what we want to do here, although this example, actually the example we do in step 6 is better or more appropriate. What I want to use is lab snort data. So I'm going to go to new log search, and I'm going to paste in lab/snort. Fun to say. When I click start, it's going to show me the snort data. And what snort data is security event data. That's good enough for now. It's not our data. It's its own data. It's just data we've ingested in here. And this is a better example of how log reduce can help. Because what I see right now on the screen are 1,300 various security events. I see classification of an attempted information leak. I see classification of a detection of a network scan, a web application attack, and so on and so forth. And like I said, I have 1,300 of these. Well, what if I want to start to look at these and group them together through those algorithms and special sauce and machine learning? I can do so with that log reduce. And this is a better example of the patterns it's going to show, because what it's going to now show in a moment are those classifications that we were just looking at. So now what I see is, of those 13 or 1,400 log messages, 713 of them were related to an attempted information leak. 72 of them were related to a detection of a network scan, and so on and so forth. And that's probably helpful to me to know how many of these are occurring. Now, what we're going to do next is we're going to take this a step further and use what's called log compare. The example wants us to use CloudTrail. I'm going to skip all that. Well, I guess I shouldn't really skip it. Let me show log compare through the snort data. I think it's just a better example. So let me set up the stage for my example. I'm going to modify my time. So right now what I'm doing is I'm looking at, let's start this really from scratch. I'm looking at the last 60 minutes worth of data. So this is the last 60 minutes of security event information. And there's been just about 6,000 security events. Now, once again, to get a better understanding and use that pattern recognition, I can use log reduce. And so when I click log reduce, the system is now looking at those log messages from the last hour, grouping them together and showing me the patterns, as we just saw. In this case, it's going to be for an hour long. So about 4:40 to 5:40 local time. Now, what log compare is going to allow me to do is compare this log reduce with a different time period. By default, it's going to be a 24-hour time shift. And so what's occurring is the system is now looking at the snort logs for today from about 4:30 to 5:30 and grouping them together in patterns. It's then going to look at the logs from yesterday from 4:30 to 5:30, look at those messages and group those patterns together. And then what it's going to show me is the difference or the delta percentage of those. So for example, what we see here with this classification attempted information leak, we see that there's been an increase by 2.6% from yesterday to today of attempted information leaks. Well, that might be concerning. If there's more attempted information leaks, that's probably not good. Similarly, we see an increase by 1% of outbound Trojans. Well, that's probably not good. Conversely, we see a decrease by 6% of these suspicious file names being detected. Maybe that's good that there's less of those. And that's what log reduce with log compare allows us to do, compare with another time period. Now you might say to me, all right, well, comparing Tuesday afternoon and Wednesday afternoon isn't really helpful to me. I want to compare Wednesday afternoon to last Wednesday afternoon. Well, I can modify my time shift to be minus 7D. And so now I'm looking at 4:30 to 5:30 today and 4:30 to 5:30 last Wednesday, and going to see the differences. And so those are two really helpful features. Log reduce is a really important feature for Sumo. We got our first patent on it. And so I don't know that we can totally claim the idea of grouping things together. That's really not patentable, but there is some level in there of grouping things together using machine learning and all that we do have a patent on now. And are very proud of that patent as well. It hangs in headquarters. So I wanted to show that feature. And then what the other things in Lab Guide are showing you is the ability for you to utilize that delta percentage. So for example, in the Lab Guide, there's this Lab Guide of looking at the AWS data. But what we can do here with this last line is look for a specific percentage. So for example, and this is not, let's modify this example a touch. Maybe seeing that something increased by 1.8% might not be important to us. But seeing that increase by 20% might be important to us. And so what we can start to utilize is the delta percentage and where clauses and start to say, only show me if it's above 20%. In this case, I don't think anything is going to return. Maybe that one last line will, but we can start to utilize that filtering. So here we see only this one showed up. Everything else was within a more, maybe a more tolerable range. All right, let's see. I think we're in the home stretch here. Let's see, what else do we have left? Let me go back to my Lab Guide. See anything else really in here? Log explain. Oh, log explain. Log explain is a very rough way to end today, but we can show it. It's a busy feature. What it allows you to do, this really product management want us to show this. What it allows you to do is look at structured logs and start to look at those events that occurred within those logs and start to specify what's called an event of interest. It's a little bit different. We used the EOI event of interest term earlier. This is not the same usage, but look for an event of interest or something interesting as a conditional statement and call it the event condition. And then look at other events of interest and call it the against condition. And we can start to, as it shows here, look at a control data set, look at an event of interest data set, and start to do some comparisons. I'll just show the example. I really don't want to get bogged down in the details. It's a feature you might use. I don't want to badmouth it, of course. It's a great feature, but it's just very specific. So what we're starting to see here is, what we're starting to see here are our as it's called, an explanation. And then we're starting to see that test versus control. And we're starting to see those two groupings compared. Let me see if I have better information on it. I really don't think I do, though. Yeah, here. So as mentioned, it allows us to compare the sets of structured data. And so it allows us to create a control data set. So yeah, it's really kind of a anticlimactic ending here, but nevertheless, wanted to at least mention it to you. All right, so what we're going to do now, actually, we're a little ahead of schedule. Once again, I just apologize for today being bumpy. Those labs, some of them were working earlier. I tested them. We actually even did a class this morning and everything worked great. So I'm really not quite sure what happened there. Somewhat ironically, I guess I could use Root Cause Explorer to figure out what was the cause of my issue, but I will do that away from a Zoom meeting. So what I want to do now is get you into the exam. So as a reminder, that's why we're here, or one of the reasons we're here. And so we want to take that exam. So we're going to log out of Sumo Logic. And then we're going to log into our personal or private or professional training account, excuse me. Sorry, I'm trying to type and chew gum at the same time. And so we're going to get into Sumo Logic. We're going to go into our certification tab. So once again, home, sorry, maybe I'm going a little too fast, but home is where you want to go first, then go to certification. And then we want to get certified. Once we're in the lab portal, or the learning portal rather, we will go to get certified. Once we go to get certified, we'll look for the exam we're interested in, which is observability fundamentals. So right here. This one only is in English, so I don't think that's a problem for this audience. And keep in mind, we want to do the fundamental observability exam. So observability fundamentals, not observability admin, and not just regular fundamentals. And then kind of, same rules as previously. So you'll go in, you'll register for free. It's going to give you those guidelines. So as a reminder, you have, this is only 20 questions. You have 60 minutes to take it. This is as well open book or open everything. So open Google, open Sumo Logic, open documentation. There's going to be different questions, of course, different fill in the blank, matching, etc. And you need a 70 to pass it. So let's go ahead and start the exam. As a reminder, the promotion / bribery offer that we have, I'll go ahead and post that because that's important. So once you take that exam and pass it, go ahead and send that certification to us and let us give you some free food. So I'm going to conclude today. Once again, thank you for attending. I apologize once again for that kind of bumpiness. Tomorrow is going to be a Kubernetes class. So I hope you're able to join it. I'm not going to be teaching. I actually have another class I'll be teaching tomorrow evening, but I'd encourage you to join our Kubernetes class if it's relevant to you. It's pretty new. The labs work. And so just want to kind of promote that, give a little plug for it. But other than that, I'm going to, I'll just mute myself. I'll hang out here for a few moments, let you guys get started on the exam and make sure you get in properly. But other than that, like I said, again, thank you for attending and hope you can join us for another session. So thank you all.